Welcome back to lecture 9 in GRA 6036. We have been talking about hypothesis testing. Now we'll talk about interaction terms. So in project 11 you can think of interaction terms as an efficient way of comparing four different means. But I'll here present a slightly different way and to think about it. So let's go back to our example where we have these Ys that are the share of infected people for country I, and we were interested in the effect of closing the schools on the share of infected people. So the effect of this X on Y. And to investigate this possible effect, we built a statistical model, this one. And notice that in this model, the effect of X on Y is beta 1 for all the countries. So I mean, a premise of this model is that the effect of X is the same no matter what. There's only one effect. So with interaction terms, we would like to allow for the effect of closing schools to depend on other characteristics of the country in question. So let's be more clear. So here are the y1 up to yn, which are still the share of infected people in the given country, and now we'll call this indicator for school closing xi1. So it still takes the value 0 if schools are open, and the value 1 if schools were closed in the period of time over which we recorded these Ys. Now, whether or not closing the schools help might depend on other things. For example, it's important when you close the schools that the kids actually do stay at home so they don't mingle and interact and then infect each other and spread the virus. So whether or not kids stay at home might be the kids might be more likely to stay at home if the Wi-Fi connection in the given country is good, while if the Wi-Fi connection is bad, then it's harder to do online teaching and you can't have fun on the internet, so you might go outside and play football and meet your friends and spread the virus. So let's make an indicator. So we suppose that we have this xi2 indicator for all these n countries, taking the value 0 if the country has bad Wi-Fi, and taking the value 1 if the country has good Wi-Fi. So we still so the data we have for these countries now is y1, x11, x12 up to yn, xn1, xn2. Okay, and so we still need to connect the x's to the y's, so we'll do that with this statistical model where yi is equal to some function f xi1 xi2 plus some mean 0 noise, and this is for all these n countries. And this function f will be f x1 x2 equal to beta 0 plus beta 1 times x1 plus beta 2 times x2 plus beta 3 times x1 times x2. And this is what we'll refer to as the interaction term. Okay, so the point with this model is that we allow the effect of closing schools to be dependent upon whether or not the country is a good or bad Wi-Fi country. So of course with these data, if you have these data available, you can import them into R and do the LM routine and find estimates of these unknown coefficients. What we look at now is how this model allows for the effect to differ. So the effect of closing schools. So let's write down the effect of closing schools. So there will be two different effects of closing schools. One for the good Wi-Fi countries, and one for the bad Wi-Fi countries. So we'll start out by computing the effect for the good Wi-Fi countries, and then for the bad Wi-Fi countries. So that means that we look at a country where the schools are closed, so that's one, and it's a good Wi-Fi country, so the second argument is also one, and we compare that with a country where the schools are open, but it's also a good Wi-Fi country, so that takes the arguments 0, 1. Okay, so if we write out what this is, so first here, this is then beta 0 times beta 1 times 1 plus beta 2 times 1 plus beta 3, that's 3 times 1 times 1. And from here we get minus beta 0 minus beta 1 times 0 minus beta 2 times 1 minus beta 3 times 0 times 1. So when we multiply by 0, these disappear, so this one disappear, and this one falls against that one, and the intercepts falls against each other. So then we get beta 1 plus beta 3. Okay, so now we'll do the same thing when we compare closing the schools or not for bad Wi-Fi countries. So we now look at bad Wi-Fi countries, and so that means that we'll look at the function for a closing schools, bad Wi-Fi, minus open schools, bad Wi-Fi. And then we get, for this one, beta 0 plus beta 1 times 1 plus beta 2 times 0 plus beta 3 times 1 times 0 minus beta 0 minus beta 1 times 0 minus beta 2 times 0 minus beta 3 times 0 times 0, which is beta 1. So now you see that the effect of closing the schools in good Wi-Fi countries is beta 1 plus beta 3, while the effect of closing the schools in bad Wi-Fi countries is beta 1. So now we see how this model allows for the effect of such a measure to differ depending on a characteristic with that country, whether or not the internet connection is good. Okay, thank you.